Assalamu alaikum. Today we will start our next topic, that is exercise 5.6 of class 12 NCERT book. This is about differentiation of parametric functions, differentiation of parametric equations. Actually, in the previous exercise, we were having functions of this type: y is equal to f of x type, right? Now it was easy to differentiate dy by d of x directly, but here in this case, this independent variable x is a function of some another parameter t, and this y is the function of same parameter t. Here the x is function of t and y is function of t, and t is a parameter, right? Example, if we take x equal to cos theta, y equal to sin theta, obviously the functional relation between x and y is x square plus y square minus 1 equal to 0. Obviously, it represents a circle. Let me say f of general x, y equal to 0, while f represents this functional relation between the variables. Here, the parameter is theta. Now, the question is how to find the derivative of such functions, that is how to find dy by d of x. This is simply to find dy by d of x. What we need to differentiate y with respect to t first, right? Then we need to differentiate x with respect to t, right? And take the division of both the two, we will get the rate of change of y with respect to x, or dy by d of x, right? Example, if we take this example of question number 1, x equal to 2at square, means x is function of t and y is the function of t also. Y is equal to 80 raised per 4, right? Now, how to find dy by d of x? Here y is function of t and x is function of t. First we need to find dx by dt, right? Now it means we need to differentiate x with respect to t. So this is d by dt of x, right? So 2a are constants, they will come out of differentiation. The differentiation will apply to its variable, that is t. See here. Now this is exponent form, x raised per n form. Its differentiation would be n x raised per n minus 1. So its differentiation 2a is there already, right? Its differentiation t square would be 2 will come in front, and then t raised power 2 minus 1, and 2 minus 1 is 1. So this is this one. Multiplying, we get 480. Similarly, dy by dt is equal to d by dt of y, 84. See, y is 84. Now, a is constant will come out of differentiation. Now, this is t raised per 4. It is again of this form, x raised per n form. So, its differentiation would be this 4 will come in front, then t raised per 1 down 4. So, that is t raised per q. So, 480 q. So we have calculated dx by dt, we have calculated dy by dt. Now, in order to calculate dy by d of x, what we need to divide both dy by dt divided by dx by dt. Dy by dt we have calculated 480 cube divided by 480. Now 4a and 4a will cancel, 1t will cancel with 1t, so remaining will be t square. So it means that dy by d of x is actually what? T square is a function of t. Right? Let's take one more example of the same exercise, that is x equal to a cos of t plus log of, see here, x equal to a cos of t plus log of tan of t by 2, y equal to a sine of t. Now y equal to a sine of t, this is not an issue, so differentiating both sides. Okay, let me first check dx by dt. Now we need to differentiate x with respect to t. A is there constant, so differentiation will apply to the brackets, right? So first differentiation would be to cos, that is minus sine of t. Then here, see here, there is composition of functions 1, 2, and t by 2. It is not of the form tan of t, it is tan of t by 2. So there is one more function, right? So first the differentiation would apply to log. Differentiation would apply to log. So this, the differentiation of log d by d of x, if it is with respect to x, so d by d of x is equal to what? 1 by x. So this is actually 1 by x, that is the reciprocal of the argument. But log का argument यहाँ पे tan of t by 2 है, so it's reciprocal. Tan of t by 2 is reciprocal. Into differentiation of tan, that is sec square of its argument, sec square of t by 2. Into differentiation of, into जो है, that is differentiation of d by dt of t by 2. So it is actually 1 by 2 into t. So 1 by 2 will come out. So d by dt of t, right? So 1 by 2 d by dt of t is actually 1. So this is 1 by 2. So here 1 by 2. So a minus sine theta, tan is actually equal to sine theta by cos theta, but it is 1 by tan theta, so it would be cos theta by sine theta. Cos, its reciprocal is cos, sec is the reciprocal of cos, and cos is the reciprocal of sec, and 1 by 2. Right now, cos and 1 cos will cancel out, so in the denominator it would be twice sine t by 2 cos t by 2. But here we will use the formula sine of 2 theta. We will use the formula actually sine of 2 theta. This is equal to twice cos theta into sine theta, right? Twice cos theta into sine theta, right? Now, so it means that sine of theta is actually equal to twice cos of theta by 2 sine of theta by 2. So here theta is t by 2, so it would be sine of theta, that's t, sine of t here. Now put 1 by sine t, because this is positive sign, I will put it in the front, and then I will take minus sine of t. Now do the cross multiplication. This is 1 minus sine square t. 1 minus sine square t is a is there. A is there, so 1 minus sine square t is cos square t divided by sine of t. Similarly, y is equal to a sine of t. Now a sine, differentiating this, a would remain there, and differentiation of sine t is cos t. Now dy, in order to calculate dy by d of x, so this is dy by d of t divided by dx by d of t. Now dy by d of t is given a by a cos of t divided by dx by dt. Now dx by dt we have calculated here, so this is a cos of t divided by sine of t. Now taking the reciprocal, so sine t by cos t, so this is tan of t. One more question is there of this exercise. It says x is equal to, see, it's very easy. X is equal to under root of a sine inverse t, y is equal to a cos inverse t. A root is same, only here sine inverse t and cos inverse t. We need to show dy by d of x is equal to minus y by x, right? Now x is equal to root of this one. Root, 1 by, it is actually 1 by 2. 1 by 2 will go here in front, right? So this is a 1 by 2 sine t. So dx by dt, differentiation of this one. Now here you need to remember that one thing that we have used, that is d by dx of d by dx of a raised power x. A raised power x. This is actually equal to a raised power x ऐसे ही रहेगा पहले जो है into log of a, इसकी differentiation. So a raised power x यहाँ तक है ये. So this is a raised power, since मुझे t की तरफ differentiation करनी है, तो ये जो है हमारा variable है. So it is in the form of a raised power t. So पहले तो ये ऐसे ही आएगा जैसे यहाँ पे था, a raised power x जो है वो है into log of a, फिर उसके बाद log of a. लेकिन यहाँ t तो डायरेक्ट नहीं है ना, हम डिफरेंशिएशन विद रिस्पेक्ट टू t कर रहे हैं, लेकिन डायरेक्ट t तो नहीं है, इट इज फंक्शन ऑफ सम अदर, this is 1 by 2 sine inverse. So I need to, by chain rule, I need to further differentiate. It is the exponent d by dt of 1 by 2 sine inverse t. a 1 by 2 वो तो वैसे है ही, log of a भी वैसे है ही, और डिफरेंशिएशन इसकी क्या है, 1 by 2 पहले बाहर आएगा, और साइन इनवर्स t की डिफरेंशिएशन जो है वो है 1 डिवाइड बाय अंडर रूट ऑफ 1 माइनस t स्क्वायर, क्योंकि यहाँ वेरिएबल t है तो इसलिए t स्क्वायर, राइट. लेकिन ये जो ये वाला क्वांटिटी है, आप यहाँ पे देखिए, ये जो ये वाला क्वांटिटी है ये क्या है, खुद x, तो मैंने इसके बदले x लिखा है, log a तो वैसे है ही, 1 by 2 भी वहां है और ये है. सिमिलरली जो दूसरा है y इज इक्वल अंडर रूट ऑफ a cos इनवर्स t, उसको भी मैंने इसी फॉर्म में लिखा है. अब डिफरेंशिएशन, अब ये भी a रेज़ पावर t की फॉर्म का है, तो पहले तो a रेज़ पावर ये पूरा ऐसे ही आएगा जैसा है, इनटू log ऑफ a फार्मूला के हिसाब से, इनटू द डिफरेंशिएशन ऑफ न्यूमरेटर. अब न्यूमरेटर सॉरी द एक्सपोनेंट, अब एक्सपोनेंट का जब मैं डिफरेंशिएशन निकालूंगा तो 1 by 2 पहले बाहर आएगा, इनटू डिफरेंशिएशन ऑफ cos इनवर्स t. cos और sin का बिल्कुल सेम डिफरेंशिएशन है, सिर्फ माइनस की ये फर्क है, ठीक. अब ये जो ये वाला पहला वाला पार्ट है, ये तो दिया गया है मेरे को y, तो मैंने इसके वाले y लिखा है, फिर log ऑफ a भी है, 1/2 भी है, और ये साइन, और ये जो दूसरा है ये था साइन इनवर्स, सॉरी कॉस इनवर्स टी की डिफरेंशिएशन। ठीक है, अब क्या मैंने दोनों निकाले हैं, dx बाई dt भी मैंने निकाला है, dy बाई dt भी मैंने निकाला है। अब हमें चाहिए dy बाई डी ऑफ x, वो होता है dy बाई डी ऑफ t डिवाइड बाई dx बाई डी ऑफ t। अब dy बाई डी ऑफ t मैंने निकाला है y log ऑफ a 1/2, ये पूरा पूरा मैंने लिखा है। dx बाई dt ऊपर मैंने निकाला है x log ऑफ a 1/2, ये पूरा। देखिए आप, ये भी कैंसिल, ये भी कैंसिल, 1/2 कैंसिल, 1/2 कैंसिल, log a कैंसिल। अब यहाँ माइनस रहा तो मैंने माइनस लिखा है, और ऊपर रहेगा y बाई x। तो हमने क्या सीखा यहाँ पे, हमने जो यहाँ पे सीखा है वो ये है, हमने यहाँ पे जो सीखा है, चलो मैं लिख ही लेता हूँ। हमने यहाँ पे सीखा है dy बाई डी ऑफ x, दिस इज इक्वल टू माइनस y बाई x, राइट। ओके, this is equal to minus y by x. So let's set off here.